I'm going to go through and really quickly explain pure substances versus mixtures, and then also within the context of pure substances, what an element is, a compound is, a homogeneous mixture, and a heterogeneous mixture. So to start out, matter can be classified as either a pure substance or a mixture. So when we're dealing with a pure substance, all of the particles are going to be identical. Another way of saying that is that a pure substance has a fixed or constant composition. For a mixture, there are different types of particles present. So you don't just have one pure substance, you're going to have 2 or 3, and they are going to be mixed together physically. So these pure substances are not combined chemically. Instead, you have 2 or more different substances that are mixed physically. For a pure substance, I can break a pure substance down into either it's going to be an element or a compound. So for elements are composed of only one type of atom. And specifically, you can find elements on the periodic table. So for example, you have silver, aluminum, hydrogen. Those would be types of elements. Compounds consist of 2 or more elements that are chemically combined. So you've got 2 or more different types of atoms, 2 or more elements. They have to be chemically combined. So a good example would be H2O, water. So you've got 2 elements there. You've got hydrogen and you've got oxygen. For mixtures, you can break them into homogeneous mixtures and heterogeneous mixtures. For homogeneous mixtures, their composition is uniform. What uniform means, it's the same throughout. For heterogeneous mixtures, they do not have a uniform composition. And so the example that I like to use for homogeneous versus heterogeneous, if you put it into colloquial terms, tomato soup. Since tomato soup has a uniform composition, it's the same throughout, it's going to be homogeneous. What I like to think about, can you eat it in the dark? So for example, for tomato soup, you could eat it in the dark. You get the exact same thing every single time. So each time you take a sample, you will get the same thing. For a heterogeneous mixture, you will not get the same thing each time. So the example I like to use is chicken noodle soup, for example. All right, so what I'm going to do is go through. The first thing that I'm going to do is identify whether each piece of matter, example of matter, is a pure substance or a mixture. And then I'm going to break it down further into if it's a pure substance, is it an element or a compound? If it's a mixture, is it homogeneous or heterogeneous? So my first example, aluminum. Aluminum is a pure substance. Okay? All of the particles that you're looking at when you're looking at an aluminum foil are going to be identical. They have the same constant composition, so it's a pure substance. And aluminum is a single atom with a very specific number of protons, which we'll look at later on in this year. Therefore, aluminum is an element. Okay? It's not 2 or more different elements that are chemically combined. It's just one single element. Okay? For baby oil has different types of particles present. It's not just one compound or one element. It's 2 or more different substances that have been physically mixed together. So baby oil is going to be a mixture. Okay. However, since baby oil is the same throughout, it has a uniform composition, it's going to be homogeneous. Okay. For a Snickers bar, since a Snickers bar has different types of particles present, it has 2 or more different substances, it's not just one substance or one type of particle, it's going to be a mixture. It's going to be heterogeneous because it's not uniform throughout. So at the top layer you've got chocolate, the next layer you've got caramel, the next layer you've got peanuts, and you've got this little caramel-y substance, and then you got chocolate again. So as soon as you're seeing layers, you're talking about layers, it's not going to be homogeneous, it's not uniform throughout, therefore it's going to be heterogeneous. Okay. For helium, all the particles are going to be identical, so it's going to be a pure substance. You can find helium on the periodic table. It's a noble gas, and so which we will get to. So therefore, it is an element. Okay. Methane, on this example, it's provided for you. The formula for methane is CH4. Okay, so all the particles are going to be identical. So this is going to be a pure substance. Okay. However, since it consists of 2 or more elements that have been chemically combined, which can be seen in the formula CH4, so the carbon is bound to the hydrogen, and we'll study how that chemical bonding happens later on in the year, this is going to be a compound. Okay. For nickel, not like the nickel that I'm talking about as far as money is concerned, but nickel found on the periodic table, this is going to be a pure substance. Okay. And since I can find it on the periodic table, that tells me it's composed of only one type of atom, and therefore it is an element. Okay. And that's all there is